All right, let's talk about the future of electric cars. For a long time, all the hype has been about the batteries, right? But today, we're diving deeper into the hidden revolution that's happening right at the heart of every single EV. For years, the entire EV conversation has been dominated by batteries, range anxiety, and charging times. But what if I told you the next giant leap forward? The thing that's really going to redefine performance and efficiency? Yep, that's right. The real action, the cutting edge, is shifting. We're moving past the brute force approach of just jamming more battery cells into a car and into a much more elegant, more sophisticated engineering challenge: the electric motor itself. Look, the era of just adding more battery weight to get more range, that's kind of coming to an end. The new frontier, the place where all the smart money is going, is motor technology. We're talking about a whole new game of efficiency, power density, and just incredibly clever design that is completely reshaping the industry. And right at the center of this new frontier is this fundamental design showdown. It really boils down to two competing shapes, two totally different philosophies for turning electricity into motion: axial versus radial. So let's break down the two main players. On one side, you have the radial flux motor. Think of it like a traditional soup can shape. The magnetic force kind of flows out from the center and spins around. This is the dependable, cost-effective workhorse that you'll find in most mass-market EVs like Teslas and VWs. But then, on the other side, you have the axial flux motor, and this thing is a completely different beast. It's super thin, shaped like a pancake, and the magnetic force shoots straight through it, parallel to the axle. This design is all about one thing: pure, unadulterated performance. And this quote just hits the nail on the head. So why is that pancake shape so powerful? Well, because the magnets are placed farther out from the center, they have way more leverage. It's like using a longer wrench to turn a really stubborn bolt. This gives them an absolutely incredible amount of torque for their size and weight, which is exactly why you see them in hypercars from Ferrari and McLaren. It's just beautiful physics in action. But, the innovation isn't just about the overall shape. The real secret sauce is in the nitty-gritty details. And these techniques can boost any motor. First up, hairpin windings. They let engineers pack way more copper into the same space. For you, that could mean an extra 10, maybe 15 miles of range. Then you've got direct oil cooling, where you're literally spraying oil right onto the hottest parts. This lets the motor run harder for longer without overheating. Perfect for a track day. And now get this, engineers are using generative AI to design rotor structures that are lighter and stronger than any human could dream up, squeezing every last drop of performance out of the system. But for all their power, a lot of these motors share a huge vulnerability. They rely on super powerful magnets made from rare earth elements like neodymium. This is a massive headache, both geopolitically and environmentally. So the next great leap is what everyone's calling the great decoupling, finally breaking free from this dependency. Solution number one, which made a huge splash at CES 2026, is iron nitride magnets. This is so cool. By using materials that are literally all around us, iron and nitrogen, companies are creating powerful magnets without any rare earth mining. This is an absolute game changer for securing the supply chain. Now, the second solution is even more direct. Why not just get rid of the permanent magnets altogether? Automakers like BMW and Renault are all in on the externally excited synchronous motor. Instead of magnets, it just uses energized copper windings in the rotor. Now, the idea isn't brand new, but recent breakthroughs have finally cracked the code on making them efficient and controllable enough for the mass market. Okay, so we've been talking about cars this whole time, but the most radical, the most mind-bending motor innovations, they're taking to the skies. This is where we see the truly incredible leap into superconductivity. And no, this is not science fiction. High-temperature superconducting motors are already moving out of the lab and into actual flight tests. We're talking heavy hitters like NASA and Toshiba successfully testing megawatt-class motors that are designed for zero-emission commercial planes. This is happening now. So here is the magic number you need to remember: 20 kilowatts per kilogram. That's the power density, how much power a motor can kick out for every kilogram it weighs. Hitting this target, well, it's the absolute key to making electric commercial flight a reality. And to put that number into perspective, these superconducting motors weigh just 1/10 what a conventional motor with the same power output would. Let me just repeat that: 1/10 of the weight. That is just staggering. It's the kind of breakthrough that completely changes an entire industry. So how on earth is this even possible? The physics behind it is just beautiful. by cooling the motor's coils down to ridiculously cold temperatures, often using liquid hydrogen, which also happens to be the plane's fuel, you make electrical resistance completely disappear. It vanishes. That means zero energy is wasted as heat, which allows for almost perfect efficiency and unlocks an incredible amount of power. Okay, wow, we have covered a lot of ground here, from the basic shape of a motor to the materials inside it, all the way to motors that can make an airplane fly. So let's bring it all home and talk about the key takeaways from this quiet revolution. So here are the 4 big trends you gotta watch. First, axial flux motors, those pancakes, are becoming the new king of performance. Second, new magnet recipes like iron nitride and clever magnet-free designs are finally solving that huge rare earth problem. Third, smart manufacturing tricks, from those hairpin windings to AI-designed parts, are boosting efficiency for everyone. And finally, the next truly wild frontier isn't on the road at all. It's in the sky, thanks to superconductivity. So, the next time you hear about a new EV, just remember that the most exciting changes might not be the battery or the touchscreen. There's a silent, incredibly powerful revolution spinning away inside our machines, and it's completely reshaping our world. The only question left is, where is it going to take us next?